Hi there, welcome to some series today. If you have not viewed my video on sequence, I would recommend doing that. You need to understand a list and how a list of numbers works if you are going to understand how to add the list up. If you have an arithmetic list where we are adding the same number every time, your rule is a sub n equals dn plus c from what I've previously shown you. So if your rule is arithmetic, this will add up an arithmetic list. If your rule is geometric, a sub n equals a r n minus 1, that's a list where you are multiplying by the same value every single time. If it is a multiplication list and you are finite, meaning you have a beginning and you have an end point, a start and a stop, well, you will be using this formula to add up that list. If you are infinite, meaning well, you have a beginning point, but you never stop adding. You continue on until infinity. Well, this will be the rule that you were using, the formula you will be using for geometric infinite. But understand, your multiplier, r, needs to be between -1 and 1 for this to work. If not, then it is no sum, and you are done with the problem. So for all these problems, n is the number of terms you are adding up. The number of terms you are adding up, to find n, it's top minus bottom plus 1 in all these different formulas here, except for this and this. That gets back to my sequence, so be cautious. But the original ones, these three, and the number of terms you're adding up, top minus bottom plus 1. A sub 1 is the first term in that list. To find the first term, you will plug in the bottom. A sub n is the last term in the list, so plug in the top, and r is your multiplier. It is inside the parentheses. So you are going to be dealing with something that looks like that. That is called sigma, our little friend sigma. Over here, you will have your rule. Now your rule will be arithmetic or it will be geometric, and you will be not seeing the a sub n on both these. Down at the bottom, n equals something, and you will have a top. This is where you stop. This is where you start. So let's say n was 5. I would be starting with the 5th term in the list, and whatever this was, let's say it was 10, I would be stopping with the 10th term in the list. So if you think about it, starting at the 5th term, the 5th, the 6th, the 7th, the 8th, the 9th, and the 10th, that would be 6 terms. So this holds true, 10 minus 5, plus that 1 to get that 6th term, that would hold true. So to find a sub 1, you would plug in this bottom value here for n. To find a sub n, you would plug in this top value into your rule for n to find it. And then r, if it is geometric, would just be sitting right there in the parentheses. You're going to see this in action right now. Let us start with sigma. My rule, 2n plus 1. So understanding sequence, you know you are adding 2 every single time, and your 0th term would be positive 1. n equals 3. 8 is up top. So what this means is this generates my rule. You're starting with the 3rd term in the list, and you are stopping with the 8th term in the list, and sigma says add me up. So understanding that this is an arithmetic rule, it looks very similar to the dn plus c. You will be using your arithmetic formula. S sub n equals n over 2 a sub 1 plus a sub n. So to get these values, n is the top minus bottom plus 1. 8 minus 3 plus 1. Well, 8 minus 3 is 5, plus 1 equals 6. A sub 1, plug in the bottom. So 3 goes right in here. 3 goes right in here. So a sub 1 equals 2 times 3 plus 1. 6 plus 1 equals 7. A sub n, we plug in the top. So I take 8 and I plug it in there. 2 times 8 plus 1 equals 16 plus 1 is 17. So now you just jam those into your formula and see what pops right on out. Okay, so I get the sum of these 6 terms. So I'm adding up 6 terms in this list. The sum of 6 terms is 6 over 2, 7 plus 17. So the sum of these 6 terms equals 3. 7 plus 17 would be 24. So now you're looking at 3 times 24. So the sum of these 6 terms equals 72, I believe, but my math has been known to be off. So there you go. Adding up 6 terms in this list. The list can be generated from this rule. So adding up 6 terms with that list, starting with the 3rd and stopping with the 8th term in that list, the sum of those would be 72. How about we look at geometric? First term in my list will be 1. I'm multiplying by 2 every single time. We will start adding with the first term in the list, and we will stop with the 5th term in that list right there. Okay, so looking at this rule right here, that looks like geometric. A, R, n minus 1. So you will be using geometric, and since this is not infinity up top, we have a stop point. This is a finite. So you are using the rule S sub n equals a sub 1, my first term, 1 minus r, my multiplier, to the n power over 1 minus r. So the variables I need in here, we need an n again. N is top minus bottom plus 1. So 5 minus 1 plus 1 is 5. A sub 1, my first term. Well, I'm plugging in this value of 1 here into this rule. So 1 minus 1 is 0. 2 to the 0 power is 1. 1 times 1 is 1. So my first term is 1. That was just plugging the bottom in there. A sub n, my last term, which should actually be a sub 5 here, the 5th term in that list, we are plugging in the top. So it is 1 times 2 to the 5 minus 1. Well, 5 minus 1 is 4. So 2 to the 4. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. 16 times 1 is 16. Now it's just a matter of slapping those in here into this formula to see what we get out. So the sum of these 5 terms in this list is my first term, 1, times 1 minus r. Oh, excuse me. We did not even need to know a sub n. My apologies. We needed to know r instead. R is right there in the parentheses. R is a value of 2. 2 to the n over 1 minus 2. There you go. You crunch that up, see what happens here. So let's go with the sum of these 5 terms equals 1. Well, 2 to the 5th, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So it is 1 minus 32 over negative 1. Sum of the 5 terms equals 1 times negative 31 over negative 1. Sum of the 5 terms equals 31. So if you were to add up 5 terms in that list, you are going to see that they equal or have a total of 31. Let's take a look at some infinite now. We will never be stopping. That's infinity up there. We'll start adding at the first term, and we need to really figure out the rule. 1 times 2 to the n minus 1. So if that's our rule, that will generate the list. You are starting with the first term, and you are never stopping. I'm looking at this r value right here. R is 2. For an infinite series to work, r needs to be between negative 1 and 1. This r value is not, so you can say no sum and you are done. Very similar, infinite there you go, there's your rule. You are starting at the first term in the list and you are stopping never. You have 1 is the first value in this list, and you are multiplying by a half every single time. This r value is 1/2. That is between negative 1 and 1, so you can proceed. And you will also need a, your first term. So you plug in 1 here. 1 minus 1 is 0. 1/2 to the 0 is 1. 1 times 1 is 1. The sum is a sub 1 over 1 minus r. Coming through, 1 over 1 minus 1/2. Well, that simplifies to the sum is 1 over 1/2. 1 divided by 1/2, you are probably more familiar seeing it as this. 1 divided by 1/2, which is really just 1 times the reciprocal of the second. 1 times 2 is 2. The sum would be 2. So you can add until infinity, and the total of those numbers will be 2. Hope that helps. See you next time.